This is chapter 1.5 notes, limits approaching infinity. Infinite limits simply a limit where a function increases or decreases without bound as x approaches c. So limit as x approaches c of f of x equals plus or minus infinity. Positive infinity, this constitutes as infinite limits. So if the limit as x approaches a specific c value from either the left or right side that is positive or negative infinity, then we know that our graph at x equals c, there will be a vertical asymptote. Okay. Usually that's going to happen. That's going to happen in the denominator with rational functions. Y is equal to f of x over g of x. And algebraically, if g of x does not cancel or does not if there's a factor in the denominator that does not reduce from the numerator, then there's going to be an asymptote there at that x value. Okay, example 1. Find all vertical asymptotes for our function. And what we're going to do is we're going to find, we're going to factor everything that we can and see what cancels out and what doesn't. So numerator gives us x minus 2 times x minus 1. Denominator gives us x minus 2, x plus 2. The x minus 2's cancel out. There's a hole at 2, and then there's a vertical asymptote at negative 2 because this factor does not go away. Okay, so we can say vertical asymptote if the line x equals negative 2. All right, example 2, determine the limit of f of x as x approaches 2 from the left side of 2 and limit of f of x as x approaches 2 from the right side of 2, right-handed limit, for our function x plus 1 over x minus 2. So we talked about how with one-sided limits, the first few steps are always the same as limits. We're still going to plug in our target x value. If we get 0 over 0, we're still going to try and reduce and then re-plug in. And if all that doesn't work, then we'll have to provide a different answer with one-sided limits. So let's take those steps with part A. Limit as x approaches 2 from the left side of 2 of x plus 1 over x minus 2. First thing we do is we're going to plug in 2, and we're going to get 3 over 0. Now 3 over 0 indicates that we can't reduce any further. There are no common factors. Limit is not going to exist. However, because we're talking about one-sided limits, we cannot just say it does not exist. We have to be able to provide more information, such as positive or negative infinity. In this case, we know that there's a vertical asymptote at x equals 2. So as the graph is approaching 2 from the left side of 2, it's either going to shoot up to positive infinity or shoot down to negative infinity. It's going to be one of those two options. So we know it's one of those two options, so we're just going to determine which one it is based off of this test below. Okay, so we plugged in the x value, and we got undefined. We got 3 over 0. And there's nothing to do for us to re-plug in. So now we're going to just have to determine then, if it's down to our two options of positive or negative infinity, if we can just determine the signs of our fraction, whether it's positive or negative, then we can narrow down our choices. So the way that we can narrow down our choices is we just choose a decimal value that is close to our target x value. In this case, 2 from the left side of 2 means that we're approaching it from the left side. So 0, 1, 1.5, 1.9. So let's use 1.9 because 1.9 is a close enough number where we're going to be able to get a good read on the signs. So if we plug 1.9 in for both x's, we get 1.9 plus 1, 1.9 minus 2. We don't really care about these values. We just want to know whether it's positive or negative. Again, we already know it's going to be one of these two options, right? Vertical asymptote. So the graph is either going to approach positive or negative infinity from the left side of 2. So all we need to do is determine the signs, because that's all we're trying to decide between. So numerator gives us positive, denominator gives us negative. Positive over negative is negative, so we know between these two choices, the graph must approach negative infinity. Okay. Now, if we want to find the limit or where the graph is approaching from the right side of 2, we're going to do the same thing, but now we're going to choose a decimal that's appropriate for this one-side limit. So this is coming from the right side, so 4, 3, and then 2.5, 2.1. So let's do 2.1 because 2.1 is a close enough decimal value to 2, and it's on the correct side that we want to test. So 2.1 plugs in for x, 2.1 plugs in for x. Again, we know there's vertical asymptote here. We just want to test whether it's positive or negative. Then we can decide. So in this case, 2.1 plus 1 is a positive value. 2.1 minus 2 is a positive value. So we know positive over positive gives us positive infinity. So we know the one-side limit as x approaches 2 from the right side of 2 will be positive infinity.